Science. Few human endeavours command as much respect and admiration as science. It's taken us from the dim glow of candlelight to the electric brilliance of our modern cities. It's shown us galaxies billions of light years away in the strange invisible world of atoms and particles. But today I want to take you beyond the achievements of science, beyond the equations and experiments, beyond the technological discoveries. I want us to reflect on something much deeper. What does science actually tell us about the world? Does it reveal the true nature of reality? Or does it describe the world as it really is in all its complexity and nuance? Or is science simply a practical tool, an ingenious but limited way of predicting and organizing observations without any pretense of uncovering the ultimate truth? This is the heart of the scientific realism versus anti-realism debate, a debate that stretches across centuries and raises profound questions about knowledge, truth, and the limits of human understanding. This isn't just an intellectual exercise. The answers we give to these questions shape how we view science, how we interpret its successes, and how we navigate the broader quest for meaning and understanding. So today I'm inviting you on a journey into the philosophical depths of this debate. So let's begin with scientific realism, the position that science reveals the truth about the world. Realism is rooted in a profound trust in science, not just as a tool for making predictions, but a window into the nature of reality itself. For the realist, science is more than just equations and experiments. It's a journey toward understanding the true structure of the universe. Scientific realism rests on three core commitments. The first of those commitments is the metaphysical commitment. There is a mind-independent reality. The world exists out there, regardless of whether we observe it or think about it. This reality has a structure, and that structure is what science aims to uncover. Think about the laws of physics. Gravity operates whether we observe it or not. The chemical bonds in water molecules don't depend on our awareness of them. The realist insists that the universe has an objective reality, and science gives us the tools to discover it. And now we come to the epistemological commitment. So science provides genuine knowledge about this reality, not just about observable phenomena like the trajectory of a comet or the growth of a planet, but also about unobservable entities like quarks, wave functions, or the fabric of space-time. And we also have the semantic commitment. The terms in scientific theories like electron, black hole, or gene, and so on, actually refer to real entities in the world. When scientists say electron, they're not talking about some kind of like convenient fiction. They're talking about something that actually exists independently of us. For the realist, science is humanity's greatest attempt to answer the deepest question. What is the world really made of? So how do the realists defend this bold and optimistic vision? Their most famous argument is the no miracles argument, which was proposed by the philosopher Hilary Putnam. And it's a really simple argument, but it is incredibly powerful. Science, they say, is astonishingly successful. Think about it. Science predicts phenomena with incredible accuracy. It explains natural processes in profound ways. It enables technologies that have transformed the world: vaccines, space travel, computing, and so on and so forth. The realist asks, how could all of this be possible if science wasn't at least approximately true? Take Einstein's theory of general relativity. In 1915, Einstein predicted that light would bend around massive objects like the sun, a prediction that was confirmed during a solar eclipse in 1919. Or consider quantum mechanics. This theory, developed in the early 20th century, predicts the behavior of particles at the atomic and subatomic level. It's so precise that it underpins the entire digital revolution. Your smartphone, your GPS, your computer, the internet, they all rely on quantum physics. The realist says, wouldn't it be a miracle if these theories work so well without actually corresponding to reality? For the realist, the success of science isn't a mystery. It's evidence that science is uncovering the truth about the world. But realists know that science isn't perfect. They know that theories evolve and sometimes fail. So how can they reconcile this imperfection with their belief in truth? Well, the answer to this lies in the concept of approximate truth. Newtonian mechanics, for example, isn't wrong. It's just incomplete. It works beautifully in most everyday contexts, but it breaks down at very high speeds or in very strong gravitational fields. Einstein's theory of relativity didn't destroy Newtonian physics or even refute it or anything like that. What it did instead was extend it, refine it, and brought it closer to the truth. For the realist, this is how science progresses. It converges on truth. It's like a sculptor chipping away at the marble of ignorance, revealing the form of reality underneath. But let's just say not everyone is convinced. So now let's turn to the anti-realist, the philosopher who challenges the realist's optimism. For the anti-realist, science is not about truth, it's about empirical adequacy, about organizing our observations and making predictions, not about uncovering the deep structure of reality. So the anti-realist would say, science is a tool, a powerful, remarkable tool, but a tool nonetheless. And they back this up with one of the most powerful arguments in the philosophy of science, an argument they call the Pessimistic Meta-Induction, which is a bit of a mouthful. So here's the argument. First, you look at the history of science. Then you count how many once successful theories have been discarded. And then you ask yourself, what makes you think today's theories are any different? So let's take a brief tour through some of the history of science. So in the 18th century, scientists believed that combustion was caused by a substance called phlogiston. And the theory actually worked really quite well for its time. It explained many phenomena, but today it's completely abandoned as, well, as nonsense. And then we have caloric theory. So heat was once thought to be a kind of fluid called caloric. Again, this theory was successful. That was right up until thermodynamics came along and crushed it out of existence. And then we have the ether. In the 19th century, physicists believed that light waves travelled through an invisible medium called the ether. This idea was taken for granted. That was until Einstein's theory of relativity rendered it obsolete. The anti-realist asks, if all of these once successful theories turned out to be false, why should we believe that today's theories, like quantum mechanics, general relativity, and so on, are any different? But the anti-realist doesn't stop there. They raise two more challenges to realism. So the first of those challenges is underdetermination. For any set of observations, there are often multiple theories that can explain them. So how do we decide which one is true? Think about quantum mechanics. There are multiple interpretations of the theory, the Copenhagen interpretation, the many worlds interpretation, pilot wave theory, and so on. And they all make the same predictions. So which one, if any, actually corresponds to reality? A reasonable question, I think, And the other challenge that the anti-realists raise to realism is the theory-ladenness of observation. So essentially, even our observations aren't neutral. They are shaped by the theories we already believe. When Galileo looked through his telescope, he didn't just see moons orbiting Jupiter. His observations were filtered through a framework of heliocentrism and early physics. The anti-realist argues that this makes it impossible to claim that science gives us unmediated access to reality. So far, we've explored the optimistic view or vision rather, of scientific realism and the skeptical critique of anti-realism. But are these positions actually mutually exclusive? Do we have to choose between seeing science as a path to truth or as a practical tool? So philosophers have long sought middle ground positions that acknowledge the insights of both realism and anti-realism. Two of the most prominent proposals are structural realism and entity realism. Structural realism, often considered the best of both worlds, considers that science reveals the structure of the world rather than the true nature of the entities that inhabit it. So let's use an example. Imagine a building wrapped in a thick veil. You can't see the building itself, but you can study its outline, its shape, its dimensions, and so on. Structural realism claims that this is what science does. It uncovers the relationships and patterns that define the world, even if it doesn't reveal the true nature of the entities involved. Take Maxwell's equations, which describe the structure of electromagnetic fields. Even if our understanding of what fields are evolves, the relationship between the electric and magnetic forces endure. Structural realists argue that these relationships, these patterns, are real and knowable, even if the underlying entities remain elusive. One of the strongest points in favour of structural realism comes from the history of science. When theories are overturned, certain elements often survived. For example, the Copernican revolution replaced Ptolemaic astronomy, but the mathematical structure that described planetary motion, epicycles and so on, was absorbed into Kepler's laws and indeed later into Newtonian mechanics. And as another example, the transition from Newtonian mechanics to Einsteinian relativity didn't discard the idea of forces and motion, but restructured how we understand them within space-time. Structural realism suggests that even if specific entities and concepts are abandoned, the mathematical and relational structures of scientific theories persists. But structural realism has its limits. Critics argue that it avoids the hard question of realism and anti-realism rather than resolving them. If we can't know what the entities in a theory are, can we really say we know anything about reality? Another middle ground position is entity realism. Entity realists focus not on the truth of entire theories, but on the reality of specific entities. They argue that we can believe in the existence of things like electrons and viruses because we can manipulate them and observe their effects. So let me try and make this a bit more sort of tangible. Imagine you're working in a lab. Use an electron microscope to manipulate electrons in a beam, shaping them to create detailed images of a sample. Or think about viruses. We can observe their behavior under a microscope, track their effects on cells, and even develop vaccines against them. For the entity realist, this kind of direct interaction is evidence of reality. Even if the broader theoretical framework changes, the entities themselves are real because they have causal power. But here's the challenge. Does interacting with something prove its existence? Is it possible that entities like electrons are simply convenient fictions that help us achieve practical goals? The realism versus anti-realism debate becomes even more complicated when we consider the challenges posed by modern science. Quantum mechanics is one of the most successful scientific theories ever developed. Its predictions are astonishingly accurate, and it has given rise to technologies like transistors, lasers, and quantum computers. But what does quantum mechanics tell us about reality? At its core, quantum mechanics is a mathematical framework that describes the probabilities of different outcomes. But interpreting these probabilities has led to deep philosophical puzzles. So let's look at the Copenhagen interpretation. The wave function represents our knowledge of a system, not the system itself. Reality, under this view, is fundamentally indeterminate until it is observed. And then we have the many worlds interpretation. Every quantum event splits the universe into multiple branches, each representing a different outcome. If true, this means that there are potentially infinite parallel universes. And then we have pilot wave theory. Particles have definite trajectories guided by a hidden pilot wave. These interpretations are wildly different, and you don't have to worry about the details of each of those. It was really just to illustrate the point that they are wildly different, but they all make the same predictions. So this raises a profound question. If multiple interpretations are equally valid, can we say that quantum mechanics reveals the true nature of reality? Or is it simply a tool for predicting outcomes? Quantum mechanics forces us to confront the limits of scientific knowledge. Perhaps, as anti-realists argue, science is more about calculation than it is revelation. Another modern challenge comes from the rise of artificial intelligence and machine learning. Today, AI systems can make incredibly accurate predictions in fields like medicine, finance, and climate science. But these systems quite often operate as black boxes. Their internal workings are opaque even to the people who design them. Consider this. If an AI model can predict the spread of a disease with extraordinary accuracy, does that mean it understands the disease? For the anti-realist, black box models are a perfect example of science as a tool. They work, but they don't necessarily reveal anything about the underlying reality. For realists, however, this raises an uncomfortable question. If prediction doesn't require understanding, what does it mean for the realists' claim that science reveals the truth? So, now that we've looked at all of that, let's take a step back and consider the broader implications of this debate. The realism versus anti-realism debate isn't just about science. It's about how we view ourselves and our place in the world, in the universe. If realism is true, then science has a moral imperative. It must pursue truth at all costs. The goal of science is not just to solve practical problems, but to uncover the ultimate nature of reality. If anti-realism is true, the ethical focus shifts. Science becomes a tool for improving human lives, addressing global challenges, and solving practical problems. Truth becomes secondary to utility. Consider climate science. Should our priority be developing better predictive models to mitigate climate change, even if those models don't perfectly reflect reality? Or should we focus on understanding the deep truth about the Earth's climate system, even if that knowledge doesn't lead to immediate solutions? Finally, let's consider the existential stakes. If realism is true, then science offers us a profound connection to the universe. Through science, we can come to know the cosmos, not just as it appears to us, but as it truly is. But if anti-realism is true, then our knowledge is always limited and always provisional. The universe remains fundamentally unknowable, a mystery that we can only glimpse through the lens of our theories and tools. What does it mean to be human in a universe we can never fully understand? And so we return to the central question: what does science tell us about reality? The scientific realist dreams of a final theory, a complete and true description of the universe. The anti-realist reminds us that of our fallibility, our mistakes, and the limits of our understanding. Perhaps the truth lies somewhere in between. Perhaps science is neither a perfect mirror of reality nor a mere tool. Perhaps it's both. a deeply human endeavour shaped by our curiosity, our creativity, and our relentless drive to understand the world around us. So that was a run through of scientific realism versus anti-realism and the debate that sort of surrounds it. And it is something that is in itself without an answer. It's, we can't pick one or the other. We don't really know. I think time will tell which is the case, if either. But in the meantime, it does give us an interesting thing, an interesting avenue of thought to explore, and it also gives us a way of looking at science, not just the science we do, but what that means for us, and so on. So it's an important debate. It's an interesting debate too, because there are lots of people on either side, and there are those middle ground positions, and there are quite a few more of those sort of middle ground positions as well. So if you get the opportunity, go and read up on those. So there are some really interesting ideas floating around. But yeah, so if you found any of this interesting at all, then I would really appreciate it if you could do all the things that the YouTubers ask you to do, which is like the video and subscribe to the channel and all of that good stuff. If you think I have in some way misunderstood realism or anti-realism or either of those sort of middle ground positions, then please come and yell at me in the comments. I absolutely won't take it personally. Learning is, in my opinion, a collaborative experience. So if no one tells me that I'm wrong, then I just won't know. So if you do believe I've said something out of place, then by all means come and let me know. And don't worry about being gentle about it. And before I go, I would like to know from you what your feeling on this is. Do you think do you align more with the realists or the anti-realists? Jump in the comments and let me know, and also why you've picked that. That would be really interesting, and it'd be good to get a discussion and a debate going. So thank you very much for watching and listening. I very much appreciate you choosing to spend a little time with me and allowing me to take up some of your time and hopefully support you in learning something new and interesting about the world. Thank you very much, and I look forward to seeing you on the next one.